Good morning, ladies of calculus. Welcome again to room 15, where Larry never ends. And we are continuing to work on this note card 40. Is that which one we're on? I think so. Note card 40, which is area under the curve, right? So area, and just to summarize what we were working on last Friday, we did this one here, where we found the area on top. We subtracted this area here to get our integral from -2 to 3, and we figured that out.
You never finished the last one.
We didn't finish this one?
No, I don't think so.
Okay, well, I think we did, but we'll just do it again in case. So what we have is the integral is the area. So it's going to be this area minus this area under the curve here, right? So our area is going to be equal to our area of our triangle here, which is going to be 1/2 times our base, and our base is going to be 3.5, is that right?
Yes.
And our height is going to be 3. And we're going to subtract out the area of this trapezoid here, which the trapezoid formula is 1/2 times height. And what's our height of this? 1. And then 1 plus 1.5, base 1 plus base 2.
That's as far as we went.
But that's fine. This is just a not simplified answer out here. So this will be good enough for the purposes of working the problem out. Okay?
So you didn't want us to solve it?
I mean, if you can, but that's just really, that's sort of, if we wanted to, we could do it quickly. You'd have like, this will be 10.5 divided by 2. So that's going to be 5.25 minus 1/2 of, so you'd have 5.25 minus 1.25. So you'd have about 4. Does that sound right? But that's okay as far as simplification purposes. As far as calculus purposes, this one here is a sufficient right answer, unsimplified, okay? So yeah, so I guess the thing is I intended for it to just, we don't have to work this out, do we? Beyond that. Okay, next we come to number, this is number 1. Capital letters represent actual areas. Express integral from A to B in terms of these letters. How would you write that? What is the answer? What is the integral for this going to be? Which areas are above the x-axis? So what do we do with those? And what do we do with these areas down here? So is that our answer? For A? Yep, that's our answer. And then what do we get for part B?
A plus C plus D minus B.
Yep. A plus C plus D minus B. Okay? So that's all there is to it. And so a lot of the problems in this section of the course are going to be involved in just keeping straight. What's above the x-axis? What's below the x-axis? What order is this going in? Sometimes one tweak you'll see on this type of problem. What if it's set up instead of this? What if it's the integral from B to A? How would that change things? Well, it would change the signs of everything, right? Then it would be negative A minus C plus B plus D if you switched the boundaries. So just something to watch out for. So it'll be a kind of mental puzzling over these things. Okay, here we have this one here, use the areas shown in the accompanying figure to find. So I want you to go work those out, and we'll go over those in 3 minutes. We'll take 3 minutes to do this? Yes?
Yeah.
Yes, okay, say 3 minutes. Okay. What are you getting for A? 0.8, right? 0.8, right? Okay, B is going to be negative 2.6. C is going to be negative 1.8. Okay, then this last one's going to be negative 0.3. Let's see, it's going to be that plus that minus that, so that's going to be negative 0.3. Okay? And again, another trick they'll do is they'll reverse sometimes the order of the boundaries.
If they reverse that, like if they reversed B and it was C to B, so would that be a positive 2.4?
Yeah, yeah, that's right. So just as an example for that, that's a good way. So let's go ahead and change.
All of the equations,
Oh, you want to show the work involved for all these?
please.
Okay, yeah, let's do that. Okay, yeah, we'll just park that thing. We got to do something. So here, do you understand this one here? Okay, because what it is, it's the area under the curve between A equals X equals A and X equals B. So it's this thing here is the whole area here that's in blue. That's what that is. All right? And from this next one here, C, from B to C, okay, it's all this area here, which is identified as 2.6. But since that area occurs below the x-axis, that's what makes this negative right here, because this red area is below the x-axis. And this one here from A to C that's going to be these two areas combined, because this area here plus this one here. So it's going to be 0.8 plus negative 2.6, or 0.8 minus 2.6, which is going to be equal to negative 1.8. All right. And then the last thing we have is this one here, which is this from A to D. And so what you're doing is you're taking in this, and for part D, you're taking all these together. You're taking this 0.8 here. You're taking this plus negative 2.6 here from this area. And finally, you're adding this area above the x-axis, 1.5. And this is how you're going to get negative 0.3. That's where that comes from. So again, it's keeping track of the areas, what the area is of those pieces. Are those areas above or below the x-axis, which make these things negative or positive? So that's really all there is to it. And then to Hannah, was that your question on the other one, Hannah? About if those are negative? Let's say we take this one, part B, and we make that instead, we make that, we'll call this question part E. What if we make this instead from C to B of f of x, d of x? Well, what that's going to be, it's going to be this area here. Now normally, if we were going from B to C, this would be negative, but because we changed the order of the boundaries, it's going to take this negative 2.6 and turn it positive that way. And then as a further follow-up question, and we did this earlier in the year, let's say we have part F, that we have negative C to B f of x dx. And this is called part F. That doesn't have. So let's say we have this. What is this going to be? It'll be negative 2.6, right? Because we started out with negative 2.6. We changed the order of the boundaries. That made it positive. But then we have this negative sign out here. So it's like a triple negative. Will bring us to negative 2.6. So just watch out for little things like that. And the arithmetic shouldn't be hard at all, really. And the seeing a thing is just keeping straight what's what. That's what it is. Other questions or ideas about this one? Okay. Okay, now we have this one. I don't know how well you see it on yours. The graph of f of x is shown, of f is shown. Evaluate each integral by interpreting it in terms of areas. And so, can you see that okay on your paper?
Yeah.
Yeah. So basically, you have a 0 to 2 area, 0 to 5. Here we have a reverse of the area of the boundaries. And here also. Let's go ahead and work those out. We'll go over those in 3 minutes. And I'm guessing, these grids are all one apart, is that right? 1, 2, 3, 4, 1, 2, 3, so all these grids are one apart. So what did you get for part A?
4.
You got 4? Let's see, it's going to be a trapezoid, right? So you have your 1/2, your height I have is 3, and your base 1 plus base 2, that's going to be 1 and 5, right?
For number 1? It's only 2. It's from
Oh, I'm looking at part B, aren't I? Let's call this B. So now it's right, isn't it? Yeah, so we have 1/2 of 6 is 3, so this is going to be 9, isn't it? So that's going to be B. Now A, I'll get the right A this time. 1/2, we have a height of, well this, if we have this one from 0 to 2, that's going to be 1/2, I'm looking at a height of 2, right? That's going to be the height of your trapezoid.
The bottom part's really high.
Yeah, so here, what you have is 1/2, the height of the trapezoid, and here's base 1 and base 2. So it's going to be 1 plus 3.
It's just,
Yeah, so 4. So you're right, 4. So you just calculated a different way, right? Is that what you did? You took this triangle plus this rectangle? It's the same thing, right?
Yeah, I was just confused because on the B, you counted from,
Yeah, that's right, because what it is from this one here, I made B, these the bases of the trapezoid, right? For part B, but for A I made the red ones the bases of the trapezoid, that's all. But, yeah, a good way to do them two is put little like you can have a triangle plus a rectangle. There are a lot of ways to do this one. C, we're gonna have 5 to 7. So here's 5 to 7. So what is that gonna be?
3.
So we have 1/2, 2 times 3, and negative. So it would be -3, right? -3. And finally, this one here, 0 to 9, well, what we would have is, it's going to be this plus this, right? And then minus this one here, this one, which is going to be
Trapezoid.
a trapezoid, and we have bases here. So our area, here, for this area is going to be 1/2, and we have a height of 2, and base 1 is going to be 2, base 2 is going to be 3, so that cancels with 6, right? So that's going to be a 6. So for part D, we're going to have, actually that's going to be, yeah, -6. So for part D, we're going to have 9 minus 3 minus 6, so that's going to be, it'll be 0. Okay? So just some things to work out. Let's see. Okay, this one here, this graph here consists of two straight lines and a semicircle. Use it to evaluate each integral, and they give you the, they don't give you the, what do we have to find out for this? We have to find the what? We have to find the area of each of these things here. So this area up here is going to be one half times 2 times the height. So 1/2 of 2 is 1, and 1 times 4. So this one is going to be 4, right? And then this one over here is going to be like 1/2 or 0.5. And this one here is going to be pi r. What's r going to be? 2. So it'll be 2 squared times pi. So that's going to be 4 pi, right? So what do we have for part A here?
Pi.
We have 0 to 2, that's going to be 4. From 2 to 5, we're going to have this one be negative 4 pi. And from 0 to 7, we're going to have, what's that going to be? 4 minus 4 pi plus 1/2. So it'll be like 4.5 minus 4 pi. That's going to be your answer to this one here. Okay, well, we will come back and I'll give you an assignment to do that will be almost like a homework assignment that I think you can do. Okay, thank you.
Have fun at your jury.
Thank you.